so now we can get started. Sorry about that, you guys. All right, so today we're talking about the anatomy of a web component and what are web components, how we can build web components just with like vanilla JavaScript. There's libraries out there that will help you build web components, but we're not going to go into those today because it's good to know what's going on under the hood. But before we even get started, if you want to follow along with the slides or the code examples, which actually are the slides, then you can go to this link here and check that out. But what exactly is a web component? So the basic definition given for a web component is web components are a collection of web standards that enable you to pretty much define essentially custom HTML that has its own JavaScript defined behavior that you can use in almost any browser, regardless of whatever framework you might be using. And when I say the word component, like what we mean by that is kind of the same idea of a component as you would experience in like a front-end framework, like Angular, React. That kind of sense of a component, like an encapsulated piece of UI that has its own behavior, styles, that's all kind of bundled into one. And so typically we think of libraries like React and Angular as kind of the forerunner of web components, but even before those were popular, you think back to some things like maybe Bootstrap, for example. The Bootstrap library gave us a way, it had styles, gave us a way of presenting content and like some behaviors. But the problem with Bootstrap was that everything was like disconnected. Right? You had to get the right classes on the right elements. You had to make sure you had all of the right scripts imported. And so everything worked, but you, the user of those components, were responsible for piecing together all the right things at the very end. And it worked. People have used Bootstrap for a long time in similar libraries. But things have evolved now to allow us to define just, a single element, and you stick that single element on the page, and it works without having to worry about how all the pieces fit together. So we'll take a look at that. But why should I care? So I think one, definitely is ease of use, right? Rather than having to piece together all the disjointed parts of a library, you can just import a script, use a tag, and everything works. But in addition to that, you get cross-compatibility. So if you can write a component that the browser understands, that you don't need to ship code to interpret, then that means you can use that with whatever else you're using on the front end. So if you're using whatever framework or library you're already using, Angular, React, whatever, you can use web components alongside of those libraries. So that means that, maybe there's some third-party open source web component collection out there, and you could use that regardless of whatever else you're using on the front end. And similarly, you might be using, especially larger companies, might be using multiple different things on the front end. Well, then that means they could write a shared UI component library that can be used regardless of whatever framework was being used on the front end. It's also less code. That's not a thing that we always think about, but we definitely should think about it. These frameworks that we use can sometimes be expensive, and I think React is pretty lightweight. Angular is pretty heavy. But if the browser understands a component, then that means you don't have to ship code to teach the browser, hey, this is what you should do with this element. So it's a lot less than you have to worry about shipping on your end, and a lot less for users to have to download. And then similarly, it provides some, when you're writing web components, it's slightly different experience. There's a few different things you have to think about, and some things that you're able to do that you might not be able to do when you're writing components and a framework. Just because when you're writing web components, at least when you're using vanilla JavaScript, you are dealing directly with DOM elements themselves, which may or may not be, which definitely presents additional challenges, but it also gives you a lot of power and flexibility. And the last thing is web components are coming. I think I missed a good opportunity for a meme there, but I'll not go there today. But as web components are becoming more and more standard, and we'll look at browser support in a minute, but some of the open source libraries that we use might start using web components as well. So for example, Ionic 4, which is what we use here at Unboxed, Ionic 4 is in beta right now, but under the hood, all of their components have been written as web components, which means that besides the core UI elements, they only have to write just simple wrappers to make them work as expected with frameworks like Angular and React. So before Ionic used to just be only Angular, but now it's Angular. They're working on like adaptations to Vue and React as well, because it's pretty cheap. They already have the elements built. There's just a little bit of wiring up you have to do to make things plug and play with these frameworks as well. So even if you're not writing your own web components, it helps understand how they work. So what are those web standards that are included in the definition of web components? So one, which is kind of the meat and potatoes of web components, is the custom element spec. So that pretty much gives you a way of defining, okay, this custom element has this behavior. You can write JavaScript to define the behavior and encapsulate all that underneath a single element, and then just stamp out the element anywhere you want in your HTML. And this is the number one thing when working with web components. The second major spec is Shadow DOM, which provides you encapsulation with just custom elements. You don't really have encapsulation, and your styles and your JavaScript might kind of start mixing with what's outside, so you don't want to really do that. So Shadow DOM provides you really solid encapsulation. Your styles won't leak out, and those styles will leak in. And another thing that you have to use alongside of, or you typically want to use alongside of the Shadow DOM, is seasoned variables. I didn't know that was a thing until I started playing with web components, but it's a thing. It's pretty well supported if you don't include IE, but we'll see an example of those as well. The next is pretty small but important, HTML templates, also supported well. And the last spec is HTML imports. So this just kind of a side note there. HTML imports is kind of defunct. WebKit and Firefox have said they're not going to support it. And honestly, you don't really need it. And using HTML imports is kind of gross anyways. So we're not going to talk about those today because it's just not valuable, but you can look at it on your own time if you're curious. So the golden question here is browser support. So here's a nice graph I put together. I think the IE world is pretty, that's not surprising that none of this would be supported in IE. Edge is okay, so it supports variables and HTML templates, and everything else they have in consideration, so probably in the future we'll see those things. Firefox is pretty good, so you can use all of these things, actually, even HTML imports, by just enabling some experimental flags. However, including custom elements in Shadow DOM, but custom elements in Shadow DOM will be like first-class citizens in Firefox as of Firefox 63, and 62 just released like last week. So it's pretty much there. And again, it'll take time for users to catch on to that, but it's pretty much there. It's good. Safari supports everything except for HTML imports, so you're golden there. I think as far back as maybe 10. And then Chrome has supported all this stuff for a long time, which is not at all surprising. So with that, I think the best thing to do is just jump into examples. So here's our starting example, and this is where we're going to park for most of the time today, just to kind of play around with and get a feel for how these different things work together, especially custom elements and Shadow DOM. And then we'll look at kind of like a more real example. So right here, we see nothing on the page, but if I go ahead and inspect this page, that's not helpful. GitHub. Yeah. If you go, oh gosh, all the way back, right here, github.com/HaydenVR. Fast forward. I'm also going to not have this floating. Yeah, let's do that. All right, so let's do this. So if I go ahead and inspect this page, it's not here. All right, so I have this element Bob is cool, and you can stick whatever the heck you want as elements for HTML, but that doesn't mean that the browser's going to do anything with it, right? So right now, the Bob is cool tag is doing nothing. So let's switch over and look at some code and start wiring up this component. Let's see here. So we'll go to examples, Bob is cool. All right, so here's what we have so far. And this is the beginnings of a very simple, basic web component. So the basics of, and all we're showing here is just how to use the custom elements interface. So you always start off with a class, call it whatever you want, and it has to extend HTML element. Now, one thing to note here is that you're noticing I'm using a class, which is part of ES6. So you can, so in the case of browsers, I'm sorry, I forgot to mention with the browser support, there are a lot of great polyfills to fill in custom elements and shadow DOM where those are missing, and they work pretty well. And you can even get all this stuff to work on IE, even though none of it's supported. You can transpile it into ES4, ES 2015, whatever it is. And there's like an extra small script that kind of translates your classes defined as functions into actual classes, but pretty much you have to write classes, and we'll see why that is shortly. And then whenever you want to define this class as a custom element, then you say, okay, window.customelements.define, and then whatever you want the tag to be, and then the class definition for that component. So pretty straightforward, right? So, but right now we're not seeing anything, so maybe we should change that. I'll call the constructor, you always call the super constructor. And there's a, sorry, you know what? Give me 1 second. I need to get my notes straight. Okay, cool. Yeah, so the first thing we're going to do is we're going to add this markup right here to our custom element. So there's a couple of lifecycle hooks that we can hook into with custom elements. So the first one is the connected callback. And this fires whenever the DOM, or whenever the custom element is inserted into the DOM. So in this case, since the class that I'm working with is actually an instance of HTML element, I'm just going to say this.enterHTML is equal to template. Template being this template string right up here. So if I save that and go back, there we go. We have our nice little text there, Bob is cool, with some styles, and that's pretty nice. So nothing too crazy complicated right there yet. There's another lifecycle callback we can hook into called disconnected callback, and that fires whenever right before the element is removed from the DOM. So in case you need to do some cleanup work, whatever else you want to do, just demonstrate that. Let's say console.log. The last of me at so that the web component can get its last word in there before it's removed. So let's go over here. Let's see. In the markup, yeah. So this thing is called Bob. So let me play with this thing here real quick. Let's say var Bob is equal to document.query selector, and I'll get it by ID. Cool. So there it is. I can work with this now custom element in the same way I work with any other native DOM element. And just to see the disconnected callback working, I'll say bob.remove. And there you go. We let it get its last word in there before we moved it, so not seen the last of it yet. So that worked. Now let's see. All right, so let's make this a little more significant. Bob, and maybe instead, something interesting we can do is instead of just having this name here static, we can allow the name to be dynamic. We can let the user of this awesome web component pass in a configuration value to set the name. So we'll give this span an ID of name, and then I'll just create a placeholder variable here. And then down here in the connected callback, once I've actually attached the markup, I'll go ahead and say this query selector, and then I'll go ahead and get a reference to the name. And then what we can do is we can say this dot name dot inner dot text content is equal to this dot get attribute name. So we'll say, okay, well, if a user of this web component passes in a name attribute, then we'll just set that name. And actually, even better, I think what I'll do is I'll say this dot name. I'll give it a default name of Bob in case they don't pass anything in. And let's see here. This dot name. Yeah, we'll do that. Cool. All right, so that should work. Cool. So there's a default name, and then what we can do is I'll go find this guy here, and you know what? I need to do it here in index.html, and for the name, I'll say Bob. Robert is cool. Awesome. And there it was. Now, at this point, though, it's not so awesome because if we go look at that element and we change the name attribute here to maybe Nick, nothing changed. And we would expect that, okay, well, if I change that name attribute, then I want the content inside to change as well. And one of the things that I've found out when working with web components is that you don't have to think about this with like front-end component frameworks, but with web components and native DOM elements, you can think about, okay, element attributes as well as element properties, and whether or not you want those to map back to each other. So the attribute being, okay, the name attribute on the HTML element itself, and then the property being, okay, if I actually had a reference to this DOM element, which I can do. So if I say, I'll get Bob, and then Bob.name. If I say Bob.name, it's undefined. It's like let me call it, but it's undefined. So I would expect that, okay, if there's this like dynamic value that I'm passing in as an attribute, I would expect that I could be able to either set that as a value on the element itself or change the attribute. And one of the things you have to think about when designing web components that will be used by either internally or by like other users that you don't know about is how you want to define that interface for your web component. So, and the best way to do that is to think about, okay, what native element is this most similar to? And how does that native element handle, okay, like inputs, for example. You know, maybe you can set the value attribute, which will then change the value property, and vice versa. But then maybe after the input's been touched, you don't want changes to the attribute value to change the real value of the element that would be seen in the form, which is the value property. So it just takes some thought when you're putting these together. And for our cases, I decided that I want the attribute and the property to reflect each other. And when either one changes, the other should change and also change the text that's being displayed inside. So there's a couple other things that we can take advantage of. One is setters. So I'll say set, I'll start with get name, simple getter. And I'll return this dot name. And then as a setter, all right, so we will say, okay, if this dot name is equal to new name, then I don't want to do anything. Otherwise, I will both this name is equal to name. So I'll update the name property, and then I will go ahead and say this. I'll update the name content. Text content is equal to this dot name. And then lastly, I'll actually go ahead and I'll update the attribute. So I'll say this dot set attribute name, this dot name. So we'll go ahead and see how that works out for us. All right, so here's Bob. And if I say, now I can say Bob.name, I can get that reference. And I can also say Bob.name is equal to Philip, and it changed the text content. But just with what I've wired up so far, yeah, we can actually see, and also the name attribute as well as the property have now changed. Now, there's one last thing. If I go ahead and change this attribute here to say maybe Jeff, it's still not changing. So that's one last change I want to make. So there's actually a pretty cool another part of the custom element lifecycle where you can choose certain attributes, HTML attributes, on your custom element that you want to watch. You want to watch them if there's any changes. So there's two things you have to use for that. The first is, let's see, attribute changed, call that. That receives three inputs. It gets the attribute name, the old value, and the new value. And then you actually have to tell it, okay, of whatever attributes that might be on your element, which ones do you want to watch? So you actually have to set or create a static getter, static get called observed attributes. Make sure that's right. Yeah, okay. So static get observed attributes. And that needs to return an array of strings of the names of attributes that you want to watch. So what we've got going on here so far is, okay, this means, okay, I want to watch the name attribute on the HTML element itself. And then whenever this changes, then this callback will be fired. And I can put additional ones in here, like if I had an age attribute that I wanted to allow or different things, but we'll just say name for now. Now, in here, there's different things you can do in here, depending on if you have a lot of different attributes. You might want to set up like a map of functions from the attribute name to a handler function. But it's just one attribute, so we'll keep it simple. So in this case, we'll say, okay, I know it's only going to be name, so I'll just say, let's see. So in this case, if the name attribute changes, I want to reflect that back inside to the name property as well. So first off, let's see, if old value is equal to new value, obviously I don't want to do anything, so I'll just return. Otherwise, I'll say this dot attribute name is equal to new value. So in effect, I didn't need to do this, but just to demonstrate the power of this callback here. In effect, I'm saying, okay, if this dot name is equal to new value, so then that's calling the setter, which will then update the property, update the text, and then would also reset the attribute. But we could get stuck in a continual loop here, but since we have these checks here, that won't cause any problems for us. So we'll go ahead, save that. Go back over to the console. Oh, geez. I think we're okay. Oh, I know why. That's because let's just try an undefined check here. So this is actually going to be called at the beginning. So right now we have a name attribute here. So in that case, this will actually be called right when, like initially for that initial value. And in this, we're getting this error right here because that for that initial call, this name element is actually, I don't have that reference yet. So let's see my setter if this dot name, then I'll do this. And that should fix that problem. Cool beans, we're all good. So let's get that reference to Bob again. All right, so as before, I can say Bob.name is equal to Alex, and that changed, all good. And if I inspect this guy, we'll see that, okay, the attribute name is also reflected. Now, with the recent changes we just made, if I change this to Nick, that will also reflect back to the property inside. So doing that like back and forth reflection, that's just how I decided to implement this component in particular. You may or may not want to do that depending on the use case, but it kind of makes sense to do that. At least it makes sense for this use case. Now, that's pretty much the basics of the custom element API. There's one other lifecycle hook that I couldn't think of any use case for. It's called the adopted callback. You can look at read about it more later if you want to. But it's pretty much like if an element is like adopted by another like parent node. I don't know. I couldn't think of a use case for it. I think it's kind of edge casey, but it's there. That's the thing that you want to try to do. Now, at this point, I've only used the custom element API. I haven't used the Shadow DOM API at all. Now, actually, before we get there, I'll do one quick change. Now, you could foresee a case where you have multiple instances of the same web component, and doing, let's see, in our connected, yeah, okay, in our connected callback, doing this right here isn't the most efficient way of setting the template for this component, because anytime I say I use this.inner HTML as a setter, the DOM has to reparse whatever I'm trying to stick in here. And in our case, it's not going to make any difference because it's just like a paragraph element. But in the real world, you might not want to do that, right? So I can do a quick trick, and this is where the HTML template tag comes in. It's really simple, but important. I can change this up slightly. Let's see if I remember if I get this right. Look at an example. Okay, so we'll do this. So we'll say that the template variable here is actually a document.create element. We'll call it, so we're creating a template element here. And then we'll say, okay, template.enterHTML is equal to this guy here. All right, so then how we can use that is, let's see, we'll come back down here to our, and so instead of this, we can say this.append child. So now we're going to append a child to our custom element to fill in its template. And we'll say template.content.clone node and true. Boolean flags are always confusing, but in this case, clone node says, okay, true means you want to do a deep clone of the content. So this is pretty much saying, okay, let me take the content of that HTML template element that the DOM already knows about, and we'll just clone that content and append it as a child to our custom element. So that way, you're taking content that the DOM already knows about, so the DOM doesn't have to reparse content every time, just to parse it this initial time. And so that saves you some overhead in the future if you have multiple instances of the same element. So we won't notice any difference. Okay, cool. So it still works, all good. And that's pretty much the use case for the HTML template tag. So not a huge thing, but it's an important difference. So I haven't used the shadow DOM API at all. So we'll go ahead and start using that. But just to kind of beforehand illustrate why we even need it, maybe you put a lot of effort into writing your custom element, you make sure it looks nice and the styles are good, but then the internal styles of your custom element are wide open, right? So some jerk could come along and say, let's really mess with the styles here. So this is ID name. So some jerk could come along and be like name, and we'll say color is pink, and background is purple. Probably gonna look disgusting. So that's not so nice. That's a pretty ugly looking component now. Like, you probably didn't want it to happen as an author of the component. So the inside guts of your component are just out in the wild. Anyone can touch them and do whatever they want. So you might not want that to be a thing. So the shadow DOM provides us with some protection. So we'll go back over here. We'll keep those ugly, nasty styles, and we'll change a few things. So in our connected callback, instead of appending the content directly to the element itself, we are going to say, we'll say const shadow is equal to this dot attach shadow, and you have to pass this an argument that looks like this. IntelliSense alpha here. So as you can see, IntelliSense is telling me that I've got one of two options. I can either make it open or closed. In this case, I'll make it open, and we'll talk in a second about what that actually means. And then we'll reuse this here, but instead of doing it just on the element itself, we'll say, okay, shadow.append child. So now we've created this internalized kind of protected space in the DOM that's internal to me, myself, inside the element, and then I'm sticking the content inside there. So and that content includes these styles here. So that means these styles can be overridden, and anything inside of a shadow tree isn't going to inherit any styles from the outside. And similarly, these styles inside won't bleed outside. So it provides kind of a nice wall between my component and the rest of the app. So if I go ahead and save, don't do that. So if I go ahead and save this guy here, oh dang. Let's see, I broke something. So as you can see, the name went away. We can fix that. So in this case, I'll need to go to the shadow itself. Name. Cool. So we're all good here. And now, even though these extremely specific CSS styles you would think should be applied to the name inside of the shadow DOM, but now they're not, because that shadow DOM provided that protection. So that means, okay, you know, nothing from the outside can impact the styles. Let's see, real quick, we'll talk about the difference between open and closed. So right now, let's see, we'll go over here. Let me get Bob again. So an open shadow DOM, which is typically what you want to use, provides pretty good encapsulation. You can still pierce through that barrier, but you have to do it on purpose. You can't do it on accident. So right now on Bob, I can say Bob.shadow root, and I can still access the contents inside the shadow DOM. So this is what I get from an open shadow DOM. If I change this to closed, pretty much means the internal contents of the custom element are at this point completely shut off for the rest of the world. There's really no way to get through that barrier unless you explicitly provide a way in. So at this point, it doesn't even know that the shadow root exists. Creating a closed shadow root is a bit too, it's just a bit paranoid. You don't really need it. Most examples you see will create an open. Because if you create a closed and for some reason a user of your component or yourself later on using that component, you need to get to the inside, you won't be able to. So creating a closed shadow is just maybe a little bit annoying. Just keep it open. Now, you might want to be able to provide some way to impact the styles a little bit. So maybe you don't want a user to just go all crazy and set whatever the heck the styles they want on your component, but maybe you want some things to be changed. And so then that's where CSS variables come in. You also hear them referred to as CSS custom properties, but that's really confusing. So, and really in documentation, you see both terms used, which is confusing, but I prefer to call them variables because that's what they are. And you see, when we use them, you'll see that's how they're used. So I can say, I'll change this slightly. So if I want to use a CSS variable, the syntax is var, and then inside a CSS variable always has to be defined starting with 2 dashes, and we'll say color. So this is me trying to use a variable called color. So I'll put it over here, comment that out temporarily, and that's me trying to use a color variable, expecting someone from the outside to set a color variable on the host of this element. So if we go over here, well, that didn't really work out because color isn't defined. So it's kind of neat with this. You can actually provide a fallback value. So if nobody from higher up defines color, it'll still have this fallback value. It's still orange, it still looks nice. I personally don't actually like to use this. I think something that is a little more intuitive is when you're working with, we'll talk about more of these in a second. When you're working with Shadow DOM, there's 2 pseudo selectors you can use. One is :host and the other is : slotted. We'll talk about slots in a minute as well. So I'm going to go ahead and use that host selector And I'll go ahead and just define color up here. I feel like that makes it more clear about the kind of variables that I'm expecting if I can define all my variables in one place at the top and then use them down low. So that's providing my fallback value as well as just making it a little more clear what variables are expected in this component here. Now, what I can do is I'll go over here, I'll target, let's see, Bob, as we called it. Yeah. So if you want to set a CSS variable from outside of the shadow DOM, pretty much you have to set it on any parent of the shadow DOM. So pretty much anywhere, but it usually makes most sense to actually target the host, which in this case is Bob is cool. So I'll target the Bob ID, and I'll just say color, and I'll make it purple. So put it over here, and the text has been changed to purple. One thing to call out about the host selector is that this selector is not strong at all. So any styles from the outside will immediately override these things, no matter how specific the outside styles are, which is probably what you would want. All right, next we can, or before we move on, any questions so far? Okay, cool. All right, the next, and probably last most important thing about Shadow DOM is the idea of slots. So again, back to front-end frameworks, not like we're used to, like we use Angular here. And so in Angular, we're used to this idea of transclusion, or in more recent versions of Angular, ng content. So you can do, again, the same thing with your web components. So maybe in my usage of the Bob is cool element, maybe I want to have, I don't know, maybe some like description in here that talks about how cool Bob is. Let's see, Bob Boberson has a lot of great business ventures. Right? And so I want this to be displayed somehow inside the element itself. So right now, okay, nothing happens with that content. Well, that's okay, because I can go back to my web component and I can create what's called a slot. All right, so when you create a slot, anything that's put as a child of your custom element goes inside that slot. So now if I say this, go back over here, and here's the content that I inserted into my custom element. Now, this brings up kind of another, I guess, curveball when working with Shadow DOM, is you'll notice that even though from an HTML perspective, it looks like this is inside here, you know what, just to, let's see, I want to make this a paragraph, just to make a point here. Make sure that'll work. Yeah, okay, cool. That'll work. So if you notice, even though this is a paragraph inside of my custom web component, the styles from right here didn't actually apply to the content inside of the slot. So if we inspect this guy now, the reason that is because technically this content right here isn't technically inside of the Shadow DOM. It's only being displayed in the Shadow DOM. Because if we look at it now, we'll see, well, when inspecting the DOM, it looks like that this is a sibling of the Shadow root, not actually inside of it. So if I look inside, here's my slot, and this refers to some outside content, but technically that content is still outside of the Shadow DOM and inside of, here's a new term for you, what's called the light DOM. I think light DOM is kind of a goofy term, but light DOM is pretty much refers to anything that's not inside of a Shadow DOM. So it's just the DOM as usual, what you would expect. So major point to take away here is that slotted content is not a part of the shadow DOM. It's part of just the normal DOM of your web page. However, I can still define some styles from within my web component that will be applied to slotted content. So I can say : slotted, and if you want, you can use it as a function and pass in a selector to slotted. So in this case, I'll say, okay, if I have any slotted paragraph, I want its color to be, I'll reuse that variable from up there. Go back. Okay, so now I was able to apply styles or define styles from inside the shadow DOM that apply to slotted content. However, one thing to call out is that you can only go one level deep with this. So, I mean, this is just the P by itself is just going to target all paragraph elements. So if I come back over here and I create another child of this paragraph and say more cool stuff about Bob. That didn't do what I expected, but I'm pretty sure, yeah, there's some restrictions around this. Like I think if you try to do, let's say, that's special. Let's say, there's some restrictions around how deep you can go with that slide selector. Alright, so this should target all paragraph elements. Okay, yeah, so if we go back here, once you get this deep, yeah, you can't go any deeper than this. So this slotted content actually won't be picked up by the slider selector. So you can only go that one level deep before the styles just don't apply. And also with the slotted selector, it's very non-specific, so it's good for like applying some default styles. But the user still has full control over the styles for that thing. So any styles that they apply to slotted content are immediately going to override any slotted selectors inside here. One last thing about slots is you can create multiple slots. So we'll give this a name of subtitle. I can actually say yeah, we'll do this. All right, so if I say slot name is equal to subtitle, so then I've created two different entry points for content from outside to be put in. It's not super significant from this example, but this is called the default slot. I can name this as well if I want to. But if I go back over here and I create something else, like, I don't know, let's take a button, because why not? We all like buttons. Hey, I'm a button. And if I say slot is equal to subtitle, I guess calling it subtitle wasn't very important. We'll say controls. So this right here is saying, okay, you know what? Hey there, Bob is cool. I want you to take this guy right here that I'm giving you and stick it inside of your slot. That's called controls. I'll change this to controls. That maps back to this guy. And I'll say if I get a button in here, I want the background to be orange. Background. Alrighty. Oh. look at that one example that doesn't work. So it was this one, but that should have worked somehow. I'll figure it out later. Sorry. Okay, but you can do that, trust me. So yeah, All right, so that pretty much covers the basics of custom elements and what you can do with Shadow DOM and the different kind of tricks you can play with those APIs. Those are the most important things to kind of wrap your mind around when working with custom elements. So, any questions about what we did here with Bob is cool? No? It looks terrible, but you know how it works. Just out of curiosity, if you want to go back later, I put together kind of like a more like real life example of, you know, a custom element you might actually build for an application. It's just kind of like a fun like little tab thing you might want to use as like form control. You know, so we'll look at it real quick. The usage of it looks like this guy. So you've got a parent cool tab, which is, so this guy is a custom web component. These guys are all also web components. And they like emit custom events, so you can see when they change and stuff. So if you wanted, you know, maybe a better example, you can go back and look at that one. But Bob is cool is, you know, nice to play with first and how stuff works. Wrapping up, it might not always be the most practical thing to, you know, if you have a use case for web components, to actually write them with vanilla JavaScript. So there's tools out there to help you out. So Polymer is by far the most important one. So Polymer is actually a project from Google that kind of provides, I guess, lightweight wrappers around kind of next generation web standards to kind of help and kind of make it easier for developers to take advantage of those things. So Polymer, again, Polymer is very, very lightweight. They do some other things besides just web components, but it's definitely by far the most well-known thing that they work on is web components. So definitely check that out. Another less used one is Stencil, which came from the Ionic framework. So Stencil is actually a compile time tool. So Ionic has created, or the team at Ionic has created kind of a, put together almost like a language, if you will, that looks, it's written in TSX files, so TypeScript with the funky HTML inside, like you're writing React. So if you look at examples of Stencil files, it looks like Angular and React had a baby, and that's Stencil. But the cool thing about Stencil is that it actually doesn't add any, there's no code that you have to ship to your end users for Stencil. Stencil just defines all these decorators, so it really takes advantage of TypeScript. And then it transpiles all of that into exactly what we were doing here, except it kind of abstracts all the messy details away from you. So that might be a good thing, might be a bad thing. Let's look at some other examples, and again, with knowledge, yeah, so they kind of merge together the whole property versus attribute thing. If you look at their examples, they don't really differentiate. So, you know, you're kind of accepting their standards and their way of doing things when you use Stencil, but it definitely looks pretty cool and pretty easy. Skate.js is another lightweight library similar to Polymer that's like, okay, lightweight on top of, they provide their own API that just kind of goes down to the custom elements, Shadow DOM stuff that we've seen. So definitely tools to check out. If you could choose one to check out, I would definitely check out Polymer first because it's the most mature. They released version 3 back in January, and it's been used in production. Here's some resources if you want to look at them. Just some good reading, some different helpful links. Here's a link to all the polyfills, which is great. One interesting thing I want to call out is this video right here, which is linked to a YouTube video. So in India, there's a major competitor of Uber is a company called Ola. And this talk, one of their developers talks through how they built their progressive web app for their users, but they forwent any front-end framework except for Polymer. Because in India, your users either have like fantastic connectivity or like poor 2G, 3G connectivity. And so they had to write a single app that would be usable for all those users. And it turned out Polymer was the best way to go because they didn't have to ship hardly, or they just shipped much less code compared to using the framework. So really interesting talks, check it out. So all these other things. And yeah, so that's it. Thanks for coming. Thanks for watching, you guys. You can reach me on Twitter at Hayden_dev and GitHub where this and other things are. So yeah, in closing, any other questions, thoughts, comments? Do you think web components are cool? Do you think they're crap?
So I'm curious because you mentioned cross-compatibility with web components. So have you looked into what the facilities are like in Angular, React, Vue, etc. for integrating web components? Like, do you still have to do most of that boilerplate? Does some of that get abstracted from you?
Yeah, that's a great question. So if you want to use a web component that someone else already built, we'll say Angular, for example, because we all understand that here. So in Angular, for example. There's one thing you have to do, so Angular doesn't like, if Angular sees an element tag that either is not native or you didn't define as an Angular component, it'll barf on you. So there's like one setting it to flip that says, hey, just let anything happen in the DOM. Don't complain about unknown stuff. So that'll actually let web components render. But yeah, so if you're using a web component that someone already defined and you've loaded that script, then you just stick that element in your HTML wherever you want, and it works just fine. Yeah. So there might be some stuff you want to add on top of that to work as, because working with, a framework component is a little bit different experience than working with a just native element. So in some cases, you might want to wrap a web component inside of an Angular component, just to kind of provide some of the, a little bit of abstraction that you want in the facilities that you're used to. But no, you don't have to do any of that. Yeah, that's a good question. Any other questions?
I have more questions about just the CSS and inheriting and like what you can do, but I have to run.
Okay. We'll chat later.
Good job.
Cool. All right, guys. Well, there's no more questions. That's it for now. Thanks for coming.
Good job,
Next month, the Dev Talk is October 11th, and we'll be talking about user authentication with JavaScript web tokens. And we'll have a guest speaker from Capital One coming and leading the discussion. So hope to see all of our 3 viewers back again next month.